What I would like to try to do with you is that we perform the segmentation of the images, right? And then we do a little bit of colocalization analysis. I will wrap this into a biological question, so it's more, maybe you see more of the approach one can use. So in my case, I'm interested into the synapses. So you know that a synapse is obviously the contact between two neurons. I guess you all know that. It seems we all have biologists with us today, and some of you working on platforms. I'm sure you had some neuroscientists coming to you saying, "I want to count the synapse in my images." So to do that, what I did was I did an immunostaining. So, but of course it would work if you, for example, have some labeling through the GFP, tomato, whatever fluorescent protein you express here. The main point is that we have spots, right? We have objects like in the image that look like spots. So in this case, what I did to see my synapse, you see some examples here, is that I did staining for bassoon, and bassoon is in the active zone of the synapse, on the presynaptic part, that is the part that will give the signal. And in red, you have OMER1, and OMER is one protein that is just beside the receptors on the postsynaptic side. So basically, I detect bassoon on the presynapse, I detect OMER1 on the postsynapse, and if I can detect a couple of green and red, a couple bassoon OMER, it means there is a synapse, and I should then identify, detect it, and so I can count the number of synapses, right? So, so to do so, I need to do segmentation, right? And the idea of segmentation is the following, is that an image is always have different intensity levels, like gray levels of intensity. And you have some noise, of course. And what you want to do is to spot the objects and to get this. So far this morning, Thomas gave you images which were already like this one. They were already labeled object in the image, right? He also have shown you the image with the original intensities, but he didn't tell you what he did to do this, to go from one to another, which is what we call segmentation. The idea of segmentation is to detect the objects in the image, and this goes through two steps. One step is to get a binary image, that is all objects which are, all pixels which are belonging to object have a value of 1, and the rest is 0. And the second step is to decide that all pixels of value 1 which are next to each other belong to one object. So this way you pack them into objects, and for each one you give a number, a label. Okay. So segmentation is obviously the most tricky thing, and I will propose you that we together do step by step one segmentation, and for this we will use different function from the 3D plugin. Okay. So what we will do is the following. I already tell you the I already tell you what will be the principle of the segmentation we will do, and then we will do it with some one example image app. So the first step is to detect the local maxima. Okay, so what we call the maxima, and basically here you have example where you go from there to there. So what is happening is you spot here here is one pixel which is higher intensity compared to his neighbors around, right? So this is a maxima, okay? Here you have a maxima as well, okay? Here you have a maxima as well, and so on and so forth. So using this, you will basically detect the object. That is, there will be one maxima per object. And someone is asking me whether I can use a dendritic marker like map2 to normal synapses to dendrite. Yes, if I see what you mean, you can indeed do collabling with dendritic markers, of course. And I mean, one thing, I will not go into this example now, but you can, especially if you're in culture, you can make a map2 to see your dendrites. You can make Homer or GluR1 or Vglut or Bassoon to spot the synapses. And you can detect the dendrite, you can detect the spots, and then you can decide to keep only the spots which are along the dendrite. This you can really do, of course. I wouldn't. Maybe we don't know. We can contact each other later if you want to go further into that. But this is feasible. So basically, to come back to the general point of this spot segmentation, so to say, that the first step is that we will detect the maxima. Once we have a maxima, what we will do, so here, for example, you have an example, we detect maxima, we have two maxima. The second step will be the following. What we will do is that we will obtain the distribution of intensity of the object. So basically, the maxima will be a center point, and around that center, in concentric manner, we will measure the intensity, the radial intensity in 3D around the local maxima. We will have this distribution. We will make a Gaussian fit of this distribution, and then we will decide, okay, I will decide that this is the end of my object, so I will get a threshold which defines the limit of my object around it. So another trick is, if you have a very faint object like this one, and a very bright object like this one, the advantage of this method is that you will have, for the bright object, you will have this one, and for the small object, you will have this one. So you will have both the threshold you will use to detect the size of the object will be adapted to each object. Okay? So that's the principle. And one thing we will also do is add one step, which is to give a threshold for the maxima. That is, you will most likely have maxima which correspond actually to very like noise in the background, some background, and this you don't want to use to get an object. So you will decide of a value, intensity value, and only the spots which are above this value will be considered for the next step, which is here. Okay. So here, for example, I show you only two maximum. Okay, but obviously here or here there would be maxima, but they're not there because I applied a threshold. So only the maxima which are above a certain intensity will be kept. Okay, because obviously in your image you will always have your object with a great signal, but you will also have some background, and you don't want to use the background as consider the background as an object, obviously. The second thing, and we can talk about it more details later, but of course I will come back to that after we did the demo. But of course, when you detect local maxima, you should be aware of noise. Basically, any peak level of noise will be spotted as a maxima. So there are different ways of dealing with that. We can come back to that later. But let's try to to do this. So here I show you the what I did and what we will do. At least one thing we will do. Here I did actually it was not Omer. It was in that case it was GluR1, which is a receptor, and bassoon. And you see here that this is the original image with all the spots, and the idea is to go to segmented. Like here it's segmented because it's surface rendering. You see actually that it's only red and black or green and black. So this is a segmented image. So let's try to do that together. So you have some images from the Dropbox. I don't know if you have those. Something called A or B with Viglut1, bassoon, and those things.
So it's in the data folder. It's called Neuro, and then you have C0, CM. But yeah, bassoon red. This is the one. Bassoon red and green. Bassoon red. Which one you want? which one you want, Nicolas?
So in data, Neuro, I don't mind. So I go into the same folder as you, so you find it. Well, we can take the first one. A Viglut bassoon.
We still see your presentation, Nicolas.
Yes. Okay. That's true.
Yeah. Yes. Just share only one screen. Blah blah blah. One window. Okay. Perfect.
So I'm in data Neuro, and I will pick the first one. A Viglut1 green, bassoon red, C0 dot TIFF, and just pass it there. So this is a confocal image. So here you can go through the stack. It's not time series, right? It's a Z series, so it's confocal of fixed tissue. Huh? It's no time. It just three. So when I go through the brain section, I have some new object appearing. Those are obviously very small objects, right? So just to give you an example, here this one is less than 1 micrometer. It's 700 nanometer. Those are synapses, so it's quite small. This is a bit too much, but okay. So you see them better because I don't know. All the contrast of my screen is appearing on new zoom screen. So we have like many objects, right? So here there are big parts which are empty because it's the cell soma, the cell body, which is in the nervous system. Okay, you have all synapses. So the idea now that we want to go from this gray level to a segmented image, right? So the first step, as I told you, is to extract the local maxima. So for this, you go to Plugin, 3D, Fast Filter. And you stop me anytime I'm too fast or you got error data or whatever. So Fast Filter. And within this filter, you have to select the maximum local, okay? Which is not maximum, okay? Minimum and maximum filters have nothing to do with maximum local. It's a very different thing. So this will detect the local maxima. You have to, you can define a kernel. So I don't know if you're familiar with the idea of kernel. A kernel is a bunch of pixels which are together. So basically the size of the filter, so to say.
Yeah, the radius, yeah.
Yes, the radius of the filter. So the idea is the following. You can, I'll show you, if you detect, let's say you detect one maxima here. If you make a really big radius, what it tells is, if I detect a maximum here, I cannot detect other maxima within the radius around. Okay. So basically, you have to set a radius which corresponds to a size where you know within such a radius it cannot be that another maxima is there. So this is quite the idea is the following. Maybe I will try to find some examples. Maybe not this one. Okay, let's say this one. If you consider this being only one object, the thing is that you would get a maximum here and you will get a maximum here, right? So the problem is, of course, if you put two local maxima within one object, the segmentation will give you two objects. Okay. So then in that case, what you would say is that if you use a radius, if your radius is like, yes, why not? To delete the points, edit selection, shift, what's this? Okay, so if you use a radius is round. If you use a radius, then what will happen that you will put the maximum local, and the other maximum local will not be appearing because you already spot the main one, and the radius excludes that you find others. If I was clear enough for you?
Yes, yes, yes.
So then, of course, what is this? If I go back to my fast filter and maximum local, of course, what is the size of the radius I will use now for my images is 2 to 3 or maybe 3, 3, 4 if you want to have a little bit less of maximum local and go faster. But this is up to you and your images, of course. You have to adapt it depending on the size of the object you expect, right? So let's do 3, 3, and 4. I tend to put a higher radius in Z because in microscopy, the Z axis has always a lower resolution than the XY axis. So basically, your object are rather like a little bit like this. That's why. And Thomas is smart enough that he programmed some filters where you don't need to be isotropic. You can see that the radius in Z, X, and Y can be different from each other. So it's not necessarily a perfect, it's not a radius actually. Well, a radius, not from a sphere at least.
Yes, an ellipsoid. It's 3D ellipsoid, right?
Right. I don't think you need to take care of this thing.
No.
It's basically that.
Don't worry.
You just leave it the way it is, okay? And you start. So normally in your ImageJ bar, you could see 3D filtering, and it goes through the 25 images of the stack. And how fast it will be will depend on your computer, obviously.
The number of CPU. Each CPU will process like 20, if you have 10 CPUs, each one will process like 2-3 slices.
So in case you're at home with your home laptop, 10 years old, and not in the lab with your brand new PC, what you can do, of course, for this demo is that you just define a region, you right-click, duplicate, you duplicate, and you just get a very small image, and everything will be much faster, right? So you can really do that for the demo, it will be completely fine. So what do I have in so the image is by default called 3D maximum local. At first you don't see anything, but there are things. So you can see that we have local maxima. Okay. So I can spot them. So it can be that some local maxima are actually a group of pixels if they're the same intensity, which will not be give a problem for the segmentation for the next step. Is that all right so far?
Yeah, it looks okay. Huh? Go.
So the second step will be each of those maximum local we will bring to the image, and we will measure the radial distribution of intensity and define a border threshold. So this is spot segmentation. So there are several options, and I will go through it slowly. The first one, which is very important, is a seed threshold. So what is a seed? The seed are the maximum local. Basically, the seed that from which we will grow to find the object. And so it's important to choose the right threshold. That is the question. Of course, as I told you, we can actually I can do that if we merge the channels. We'll have obviously some spots which are here not at all in the in objects, simply because they're in the background, right? Voila. So obviously, if you really dig for it, you have some background, right? And so you can have local maxima detected in what is just background. So you don't want to keep those for your objects, right? The same as here, for example, this could be detected. So the seed, I go back to it. So here the seed threshold is important. So in our case, we can put 50 for this example, but of course it would be up to you to look at your image and decide what is the maximum, the local maxima intensity that means it's an object, and what is the threshold underneath below which I decide it's no object, right? So let's put 50 here. Okay, there may be a question in the. Sorry, where is the seed spots? You mean the spot segmentation plugin 3D? If that's a question, it's this 3D spot segmentation. Is that answering the question? Yes, okay, it is. So once you, yeah, it's called seed spots here, but it's called spot segmentation, right? So seed threshold, let's put 50, but this is basically what I told you. What are the local maxima we keep for getting the object? Then we have different methods to define the local threshold, which is the threshold of the border of the object, which is specific to each object. So one possibility is to give it constant, that is, all objects of the image of the same, and then you decide you put it there. It would be the local background is so much and it's constant. Then you have other possibility, which is local differential, which you can set here. Local mean, which is here. And in case of local mean, you would also look at the intensity around the maxima, but only with in 3 radius, and you would give a weight to each. And the one I propose to you to explore is a Gaussian fit, which is a kind of most advanced mode, I would say. And Thomas, he will stop me anytime I say any mistakes about.
Oh, sounds good. Sounds good. Perfect.
So every time you choose this, you have to see where you go. And constant is here, local diff is here. The local mean means you're here, local mean. And Gaussian fit, you go, of course, here, Gauss fit. So basically, if you choose Gauss fit, everything which is here, you don't care. You only look at those. So you have three items. So what are those? I can show you that here. You see my PowerPoint is neat because it's a whole screen share. So one thing is that you need to show, where is it? Voila. One thing that you need to give a radius max. So Thomas will help me to define what is exactly radius max, but approximately the idea is what is the maximum radius, that is the half of the diameter of the biggest of your objects in the image. So you would not, the idea is that it gives a little bit of a selection of your image according to the size. Because obviously if you do, if you on the PowerPoint, you see that we look at if we do radial distribution around the maximum local, the question is how far are we going with that? Okay, you don't want to do the whole image with that. So you want to give an hint about what is the size, the maximum radius you want to explore. Is that right, Thomas?
Yes, exactly. You compute the intensity within this radius. So it should be a bit more than the size you expect for your spot, something like this.
Exactly. And so that's one thing. So this should be the let's say, so in our case, you can put 10, it's fine. I just check that for you. And then there's the SD value. So the SD value is rather sensitive because it's working like this. Once you will have the radial distribution of the intensity around the local maxima, it will give you a distribution, and the program will do the Gaussian fit of this distribution. So you will have a Gaussian distribution. Then a Gaussian is, you have the mean and you have the standard deviation. And the way it's coded is so that you say SD value equals so much, means that you take 2 times the SD from here to here. You multiply by, or let's say if I put 2 to make it more simple, if I put SD value 2, it would mean that I have, at the level of SD, I have one length here, and I multiply this length by 2. So basically, I have 2 times the length, all right? And once I have this, I place it so it's fitting into, so it would be approximately here. And then I can read there a number in intensity. And this will be my local, the threshold of the border of the object. Was that clear?
So the larger the value, the larger the object will be.
Yes. So of course you can decide, okay, I put SD1 and you will cut the object here. 1.5, I cut the object here. 2, the object is here. Okay, 1.5 is here and 2 was here maybe. At some point, because it's going like this, 1.5, 2, it's not making so much difference. So basically, if you put 2 times SD, you will make a cut, so the surface here corresponds to more than 95% of the surface of the Gaussian distribution. Okay. Of course, then we are going into the difficult question of where is the limit of my object? Is your object finishing here? Is your object, that's PowerPoint, or is my object finishing here? Right. So that's, then at this stage, I think it's you may all know it already, because I guess you're not completely newbie with image analysis, but it's good to state it clearly that it's up to the biologist to validate the segmentation. Okay, to say my object is here, so now I want a segmentation procedure that finds the object the way me as a biologist I define what should be the object. Okay, so this is a little bit up to you. But the main point is that with this method, as you can see from the two distribution for faint and big objects, the advantage is that you will have individual objects, and in both cases, you will have, let's say, 90% of the surface of the Gaussian. So you will respect each object according to their own distribution. So you can have very big, very intense object and very faint object, and the volume is quite similar, which is different from the intensity thresholding, which is classically used.
Nicolas, you wanted to try? Try.
So here we are. So if you put, let's say, 2, I like 1.5. 2 usually for me gives something a bit slightly too big, and mod block is good. Then you can, we don't need to do that now, but you can define also some size filter.
The size of the objects at the end.
Seeds, you use 3D maximum local, and spots. So this is this one, okay.
So for seed is the name of the image. So our image, the name is 3D maximum local. It's the name of your image if you have seeds. If you don't have seeds, it will automatically compute the maximum local.
Okay. And okay, and we'll just, so in the ImageJ bar you see segmenting slice, and once I reach 25, it's done.
So this can take some time for very big images.
So at first you don't see anything because voila, it's and now we have a segmented. The image is indeed the segmentation which has been proceeded. Okay, if I want to be really on the same of the image. Need to see everything. Is it working for you, all of you?
So in the log, you should have some information. It says like create object, create the libage image with 5,000 objects. So we detected 5,000 objects inside this image. So you take this image, you should obtain more or less the same number of objects, depending on the threshold and the seeds you chose. Yeah, anyway, I think you gave the segmented data. So
as well, yes. So
you can play with the segmented data. So you want to put this into 3D Manager to show 3D Manager can handle a lot of objects.
3D Manager, right? So that's what we used yesterday, this morning. And so I click on the right image and I just add image.
It can take some time if you have a lot of objects. 5,000 is still okay, but if you have 100,000 objects, it can take some time to One thing I didn't say for 3D area, it will only add the object inside this area. In case you don't want to add the object of inside the whole image, but select the object inside the area, you can create an array, add image, and it will add the object inside this array.
Okay, maybe a question. I don't have any objects in my 3D Manager viewer.
You have 5,000 objects?
Not any. You have to first, before you click add image, of course you need to click on the right image. Like for example, if I click on this one and I give add image, it will not bring anything because this is just a gray level image, so it will have problems. So I have to really activate.
Sometimes there's a problem of synchronization, of update, of refresh. So in case you don't see nothing in the list, just wait a bit or just rename an object or do something.
Okay.
Sometimes the refresh is not so good.
Seems okay now because
good, solve, problem solved, good.
Okay, since I will have a little bit of problem because to show what could be the problem, I made add image on this one, which is a gray level image. So
And
it's adding.
Don't do this, please. Because each gray level is one object, so it will go crazy. Thank you, Nicolas. So you can crash to the manager, no problem.
I think I did. So
you want to show?
I come back.
You want to show colocalization? Yeah.
In while Fijis is, yes, I will. So one thing about what we did was, I told you we will come back to that because I think it can really mess the whole spot segmentation. So of course there's a noise issue with the idea of detecting local maxima. So in my case, the images I give you have been deconvolved. And so you can software, but there are others to deconvolve the image. And at least please perform some noise filtering before treating the local maxima. Especially because, well, depending on your signal to noise ratio, obviously, maybe the noise is lower in intensity than the signal, so you can simply use a threshold, as we said, but it may be a good idea to filter the noise out before you go for such local maxima detection. And actually, there is in the 3D plugin we present to you today, a Maxima Finder that includes a noise parameter, isn't it, Thomas?
Sorry.
So now the thing, just to give you the context, was the following. So using this Gluer one and Bassoon, what I did was I did the segmentation using spot segmentation, and I wanted to count the number of synapses. So in that case, what I was counted was a number of intersecting objects, right? And here you can see that I got some density in synapses. And we have a mouse model for brain disease, Huntington disease. And in the brain of those rodents, we have a decrease in the heterozygote or homozygote of those knocking mice model of the density of synapses in the stratum. And some collaborators were using a tool which was, the idea was to find some therapeutics, and expressing this enzyme helped to restore, partially at least, the synapse density. So we were really happy. We could see that we can increase synapse density by expressing SIP in the brain. In the meantime, in parallel, I was also making a segmentation of the VGLUT1 button. That is, here I see the number of buttons, right? And what I could see was that it was completely constant. There was no decrease, no increase. So this was, and this was again a spot segmentation that you can see the 3D rendering of this. So this was intriguing. So basically what happened is that we have more synapses, that is, there are more pre and post, bassoon and Homer or GLUR1, it's the same. Well, it's the same, it's equivalent. But we have the same number of pre-synapses. So this gave us the hint that the way synapses are formed are not this one, but rather this. That is, the new synapses would come on presynaptic, which are the same. In that case, VGLUT1, which corresponds to the whole button, the number of VGLUT1 is the same, but the number of bassoon would increase because bassoon is really in the active zone. So the idea would be that VGLUT1 buttons stays the same, but instead of having one, here we would have 2 times bassoon, and of course 2 times Homer here and here. So if this is true, then we should have more object VGLUT1 which have more than one bassoon. And this is what we tested with this. And here you have the VGLUT1 in green, the bassoon, and you can see that if you check, so this is a 2D in the stack, you have some VGLUT1 with 1 active zone, some with 3, some with 2. And you can see that the percentage of VGLUT1 localizing with 1 or with 2 or with 3 bassoon is indeed modified here. So I would like to show you how we can do these kind of things with the plugin. And for this, I think the idea is to rather open the already segmented data, so we can take A and C0 seg and C1 seg. Sorry, not at all. Something like this. So basically, we take already the seg data, so they're already segmented, and we take both channels, C0 channel and C1 channel, okay? So we can open those 2 images. And we have a plugin in 3D, which is here, which is multicolor.
Yeah, first, you want just to show the data because it's black. Just
yes.
Yeah, just
okay.
to show there's something. Yeah, a lot of things. Actually, a lot of things.
So the VGLUT1 are bigger and the bassoon are smaller. It's really the small active zone within the buttons. So that's why they're different in size. So, okay, my images are mostly very tiny spots. You may have very big spots, why not? Or other shapes. And this is segmented in sense that you can see that each of them, this is a 2,889, this is 2,885, this is 1,323. So each object has its own value, which is the number of the object. So 3D, and we have multicolor here. Okay, and it would probably not work. Yes, it works. Ah, yes, it's only yes. Okay, so one thing, yes, I have the habit to give long names to images, which means that here it appears as the same. So let's say this one I will give the first line, and this one the second line. See what I mean?
I think that the problem is like ImageJ, when there is a space in the name of the image, it will just stop or cut it. So if you want to be sure that remove space or just rename your image like image A, image B, so
Voilà.
you'll be sure.
Exactly. So I can rename, and then you have, because of course, if you do colocalization in between the same channels, it will colocalize. But okay. So for example, this one. I think there's a question. I just expand the window. Okay. Yeah, not with.
Yeah.
Not for me. Or if you have it,
Yes.
you're lucky. Great for you. I don't have it. But okay, fine. Okay. So only colloc, all collocs, both. Let's say only collocs. That's fine for me. That's it. So it's quite fast, given that we have more than 5,000 objects, right? And here you can see, actually, we have like 3,700. So what's happening is the following. Here, the label here is the object of the image, the first image you choose. All right. And it shows you whether each of those objects would co-localize with an object of the other image. So if there's 0, it means on the other image there's no colocalization. That is the I think I use this one as a reference. And so the first object in this image is colocalizing with no object on the other image.
Actually, it's not exactly the first object, it's the object with ID 1, with the intensity 1.
That's what I meant. But yeah, okay, first, whatever first means, in the first object
yes,
of the list.
Yes, the first ID, yeah.
Yes, the first object of the list, the first ID, yes, indeed. That is, okay, if you want to see which one it is,
yeah,
you know what to do, 3D.
Yeah.
Add image. So the first one is this one, right? And it's here, I think.
So maybe later we try to play a bit with 3D Manager with 5,000 objects and see what we can do. And cannot eventually.
And so the object number 2 on the list is localizing with another object. And what you have here is the label of the object, right? So for example, here, the object number 9 is colocalizing with the object number 45.
So it's the number is really the ID of the object.
Yes, okay. In O1, this is the ID of the object, really.
In the second
which corresponds to the intensity of the object in the image, or the ID, which, okay, 9 is this one, of course. And it got the value 9 in intensity in the image. One thing which is a bit specific and can be very interesting in this multicolor plugin is that it also gives you what's happening if they have multi-colocalization. Like, for example, you can see here that the object number 12 is colocalizing with 1 and 2 objects in the other channel. That is, the object 32 and the object 55 are both colocalizing with the object 12 in the image, right? So that's what happened here when I was wondering about that. And I detected how many objects have 1 colocalization, how many objects have 2, how many objects have 3 colocalization, right? So that's what here we have a 2 times colocalization.
So you want to say what is V1 and P1?
Yeah, so V1, if I remember right, was because I was not looking at those things at the time, but V1, I guess, is the volume colocalization.
Yeah, between object 12 and 55, right?
Mm-hmm.
And P1 is the percentage of this volume colocalization related to the object 12. So that means like 1%. Yeah, 1% of the object 12 is colocalizing with object 55. If yeah.
So if you do object-based colocalization, the percentage can be of interest because it's you can also decide on whether you want to trust a colocalization when it's a very small percentage.
Okay, can I suggest you that you do colocalization with 3D Manager? Only you just take only 2 objects?
Yes.
Just to show that it's.
How do you want to do that? Because do we want to use objects from the same channel? Then there's no colocalization. I need to add another image, right?
So you see the problem. 3D Manager is mostly focused for one list of an object coming from one image. If you want to have 2 lists of objects, you will get like 5,000 objects from the first image, 5,000 objects from the second image. Which one is image 1, which one is image 2? So it's becoming a bit complicated. So if you have like 10 objects like before, like 3 nuclear lie, blah, 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 it's okay. You can do colocalization. The problem of colocalization in this 3D Manager, it will do colocalization between all the possible pairs. So if you have 3,000 objects, it will be like 9 million possible pairs of colocalization. So that's completely crazy. So it will crash. Definitely, you can try. It will crash. So far, if you have colocalization between 2 images and you have a lot of objects, use multicolor. If you have less objects, you can manage them with 3D Manager. You can go for colocalization. But anyway, Nicolas, you want to try the colocalization between 2 objects coming from the same image? It will be 0, but maybe just to check the values.
So I select 2 like this.
Yeah, colocalization. So yeah, so you see the information, and you will see basically the same information. The colloc, so the colloc will be the number of voxel colocalizing between the 2 objects, and of course it's 0. And the percentage of colocalization, we also have the contact surface between 2 objects. It's a bit more tricky and really depending on if the objects are not colocalizing but touching, so the surface, contact surface between 2 objects you can get. And then maybe you want to show the distances.
Yes.
So okay, Nicolas, you do what I say.
So you select 2 objects and distances.
So the same, if you have a lot of pairs, it will take ages. So you same information. So label 1, label 2, because you have 2, you can go object 1, object 2, or object 2, object 1. So you have sun is a center to center distance. So of course the same, AB, BA is the same. And then you have center border. So you have the distance between the center of object, the first object, to the border of the second object. So AB and BA can be different. And then you have periphericity. Okay. And then also you have closest center. So that means what is the closest object in the whole dataset actually. For this object number 4 is the object 1229. This is the closest object considering center to center distance. If we consider border to border distance, the closest is the same one for the first one, for example, but for the second one, you can see it's not the same one. So this one, the distance will give you a bit more than the distances, will give you the contact, colocalization will give you a bit more than colocalization, like the contact surface between two objects. Distances will give you a bit more than distances, will give you the center, the distances, and also the closest objects. So yeah, any question, or do you want to focus on something else? Or maybe just 2 to 3 minutes. Nicolas, you want to explain the different distances and things?
Yes, it was just because I saw in the table. It's you explained very well, but just it's sometimes easier with one single picture.
Yeah.
So with 3D Manager, you can really measure different kind of distances. So obviously, center to center is one thing, but of course, this center to center is useful mostly if most objects have the same size, right? You can, depending on your biological question, but then it's really depending on the scientific question you want to assess, you may better want to look at the border to border. So here we said distant edge to edge. It's actually what would be called border in the plugin.
Yeah,
So look for borders. And so border to border is one thing. Then you can have, of course, as Thomas said, the center to border. And of course, center to border, you have also to image it differently, whether the objects are far apart or whether the object do colocalize. That is, the situation will be much different if you have one object within another, if you do this kind of measurements, right? So it's up to you as scientists to interpret those data. And this is to present a percentage of colocalization, right? And of course, when you do colocalization, you have also always to see what is your reference images, because of course the percentage of colocalization can be the percentage of the volume of A or the percentage of the volume of B. In this little picture, it's the same, but if A and B don't have the same size, it's not the same result, right? So in the examples we did together, those bassoon spots are much smaller than the Veglut spots. So it's completely normal that the percentage of colocalization is small if you consider the volume of Veglut one. This is fine. It would not be fine if it was a percentage of the bassoon, because bassoon is within the Veglut one. And here we go for more like surface of contacts, which is, well, you have to really see whether you can, 3D Manager basically can calculate almost everything. It's more a little bit like up to you to see whether it makes sense for you as a scientist. So Florence is asking whether figure B is border to border. And is this border to border corresponds to closest border E here?
So you imagine you have this image with 5,000 objects. So you will measure the border distance between this object and all the object, and what is the closest object, considering this border distance to object 4 or 9. So you may have the closest object considering center to center distance, and the closest object considering border to border distance. That may not be the same, depending on the size of the object. So this is more to try to compute relationship, this kind of thing. And you can do this. So it's almost 11:30 Paris time. So let's say we have 30 minutes left. So maybe we can take some question, and then I'm sure we have a lot more to talk, a lot more to say. But maybe if you have one question, we can focus on one specific topic or do something we didn't explain properly, or you have a question about a specific measurement or specific plugin. Or... Yeah, so please. We didn't talk about macro things, so yeah,
No.
just any.
So
Jonas?
the question about segmentation from Agatha actually on the chat.
Sorry, Jonas. We'll come back to you later. Huh? No problem.
Okay, so well, I can answer quickly to that. It's because Agatha said that it seems like we segmented object for each Z slice. Actually, not at all. We really did everything in 3D. Yes. I know someone before earlier this morning asked whether we use things like 3D object counter. So there is indeed a so-called 3D object counter. 3D object counter is working in 2D and then gathering the pixels from adjacent slices together to pack them as a one 3D object. But when you go through this 3D plugin menu, you all in 3D. You all in 3D.
Everything 3D, and we will take into account the anisotropy of the pixel. So everything 3D, don't worry. Jonas, you wanted to...
So my question is, for example, we are doing microtubules or other cytoskeleton proteins, which are like filamentous in 3D. How would you do the segmentation there? Because the Gaussian parameters here basically make it that it's basically elliptical or close to round.
Yeah, you're right. Most of because of our work, we focus more on spots. So most of our plugins and segmentation and analysis is for like spot-like objects. So I must admit, we don't really work a lot on filaments. But I know it's a very interesting question, of course. For filaments, the question for segmentation is always the question of contrast. If your contrast is good, just go for thresholding. This is the first thing to do. First, so the steps are always the same. The reduced noise, like a 3D median filter, 3D Gaussian filter, reduced noise. Go for global thresholding first. If it's working, you have a big object. So we didn't do this, but it's like a 3D simple segmentation. 3D simple segmentation, you just put a threshold, it will detect all your objects in 3D. So you can detect your filament. You can put your filament in 3D Manager and then measure the volume, surface, whatever. If you have one image with your filament, one other image with your spot, you can easily do the distances between the center of your spot and the border of your filament, something like this. So your filament, you can treat this like a big object, but you can do more or less the same measurement we did for spot object, but for big object, filament object, you can do the same kind of measurement. Intensity inside and this kind of thing. But I think, yeah.
Florence has a question about colocalization percentage, but actually her question, if I get it right, is if two viruses labeled same neuron, so basically I think the question comes with what about when there are three channels, is that right? Florence?
Yes, so the question is, for example, I wanted to check if the two viruses colocalize the same number of neurons. So the idea is that we want to check if we inject enough virus of each type of virus. And the result I want to get is 100%. But for example, it doesn't happen every time. So how can I check the percentage of colocalization of these two viruses? So there are two different fluorescence, let's say, one red and one blue. And I want to check if it's good.
So I think there are two things there. First, the classical intensity colocalization, like Jacob. We are not talking about this here. So this is typical intensity-based colocalization. So it will just check localization between your red channel and your green channel. This is a classical stuff. Jacob is the perfect plugin to do this. Here we are talking more about if you can detect your objects, we use more like object-based colocalization. And I think the base is more like the multi-colloc thing. You will see all the objects in image A colocalized with which kind of object in image B, and we see with which volume or which percentage. I think this, yeah, something like this, yeah.
Yes. Thank you.
Any more questions? We have a lot of things to show you. Yeah, but we are mostly open for questions, a bit more, maybe more interesting. So now everybody can be confident enough to analyze their own data, or there's something like something I'm not sure. Everybody happy? Yeah, good. So if everybody happy, maybe we just I can do some quick, maybe just a macro, just to automate rapidly. I show how we can do a macro, and then yeah.
Well, Kevin has a question actually. Wait, is
Okay.
there any way to draw contours manually?
So there is one plugin called Manual Segmentation. It's quite a very old plugin, but I think it's still working. So basically, you just click on the seed. So basically, a lot of things we did is based on seeds. So, but sometimes you don't detect all the seeds, or some seeds are wrong. So you can choose to delete some seeds manually and just delete them, or add them manually, just like paintings. If it's seeds, it's quite easy to add or remove some seeds. If you want to draw the contour of objects that are missing, you have to go like manual segmentation. It's a bit more tricky, like what is called Segmentation Editor. And then you have LabKit. So this is really to draw manually some contours, but on all slices, on almost all slices.
Yeah, because Kevin is mentioning about serial electron microscopy.
Oh my God.
So you forget something, right?
Oh, please don't
So
do
3D
this.
electron microscopy, forget your seeds, Thomas.
Why? So 3D electron microscopy, a lot of people are going deep learning for sure, because it's the way to do this is quite difficult. And now a lot of deep learning stuff are working quite well. But yes, you're right, you need some ground truth. So for the ground truth to train your network, this is a general stuff for deep learning or machine learning. It can be either light microscopy or electron microscopy. You need to train. So we didn't see this. So before doing deep learning, I can recommend the Weka plugin. Weka trainable segmentation, right? Trainable.
How do I spell that? Weka plugin?
Yeah, inside Fiji.
Right.
All right, it's Rebecca.
Thanks so much.
Actually, I think you have to go to plugin, segmentation, and within segmentation you have Veka.
I can share my screen to show.
Yes.